Grains of sand on a beach can tell us more than you might think about the history of the planet, new research reveals. Something to think about the next time you're heading to the coast for a swim or splash around. Scientists have developed a new metric to determine what they call the age distribution fingerprint of the mineral zircon in sand. That fingerprint can then be used to reveal more about the evolution of the surface of the Earth across billions of years. Zircon is something that geologists look out for, because it can be formed when continents crash into each other. These crystals can in some cases be billions of years old, carrying a huge amount of history with them. The durability of zircon makes it resistant to geological erosion, and as it forms sediments, it stores information along with it. As the crust grinds together, forcing new rocks to congeal, a timestamp of the rock's age is preserved in its makeup. Even once it crumbles into tiny grains, it's possible to gather traces of this history. The world's beaches faithfully record a detailed history of our planet's geological past, with billions of years of Earth's history imprinted in the geology of each grain of sand, and our technique helps unlock this information, says sedimentologist Milo Barham from Curtin University in Australia. By figuring out the age distribution of zircon in a sand sample, from infants to the elderly, in geological terms, the new technique enables scientists to work out what mountain-generating events were taking place in the eons leading up to the depositing of that bank of sediment. The approach is even able to shed light on how Earth first developed a habitable biosphere, according to the researchers, peering back further in time than other methods of geological analysis. Another advantage that this new research technique has over existing methods is that it can be used to understand tectonic movements even when the age of the sediment deposit itself isn't known, a scenario that researchers often find themselves in. The team put their new method to the test with 3 case studies that highlighted how the age distribution fingerprint works, studying sediment in South America, East Antarctica, and Western Australia. For example, the sediment on the west and east coasts of South America are completely different because there are many young grains on the west side that were created from crust plunging beneath the continent, driving earthquakes and volcanoes in the Andes, says geochronologist Chris Kirkland from Curtin University. Whereas, on the east coast, all is relatively calm geologically, and there is a mix of old and young grains picked up from a diversity of rocks across the Amazon basin. The new analysis matched what previous research had uncovered about the sites. Even individual grains of sand can reveal the tectonic forces that created them, based on the age distribution of the sediment around them, the researchers say. The new technique can be used to reanalyze data from older studies, the researchers suggest, as well as to tease out more details from suitable sediment in future research. This new approach allows a greater understanding of the nature of ancient geology in order to reconstruct the arrangement and movement of tectonic plates on Earth through time, says Barham.